Uh, Thanks everyone for coming today. My name is Hany Fahim. I am the founder and CEO of VM Farms. For those of you who don't know, VM Farms is a managed web operations company. Today I'm going to be continuing a series of talks called Tales from the Ops Side. These are stories about interesting problems and technical challenges that we faced in our day-to-day operations. Today's talk is called Unpacking an Anomaly. So everything began on a quiet November day 2016. This is last year, about a year ago, when our Sentry system threw a nice error for us. Content is not a valid RSA or DSA SSH key. Little did we know that this error would haunt us for over a month. Now, to understand what this error is, you have to understand a little bit about our app. So we have, one of the features of our app is SSH Key Management. So we allow our users to basically manage SSH keys to distribute amongst their servers. So SSH keys are attached to users, which then are attached to groups, and then groups are attached to servers so they can get distributed amongst. It's a little bit of an echo. So one of the things that the app does is it checks to make sure that the keys are valid and complete. So this is an important aspect. And here's a really quick screenshot of what it looks like. Really, really simple. You just throw in your SSH key and you go. So when it gets validated, it goes through this function called parse SSH key. So it's actually pretty simple, and this function is actually quite large, but this part over here, these 8 lines, they're at the very bottom. So at this point, it's done a lot of tests. So to get to this point and still fail is very, very rare. It's really simple. So every SSH key that you see is actually a base 64 encoded byte string. So the very first thing we do is we decode the base 64 string. And very simply, we take the very first 4 bytes of that string, and if it's a proper SSH key, it should actually have the integer number 7, and that represents the length of the header that tells you what type of key it is. So very simply, just grabbing the first 4 bytes and seeing, does it equal the integer 7? And if so, everything is good, and if not, throw this error. Important pieces of information. This code was 2 years old at this time and had never, ever thrown an exception because there was probably a comment on top that says should never get here. And is really curious why it broke. And you also notice that we put a very generic exception handler over there because, again, why would this ever break? You'd never know, so I don't even know what type of error. So just capture all errors in there. Very bad idea. So we try to replicate that. Because it's in Sentry, you have the entire Python context. You know all the variables in there. So we grabbed all the same variables. We even grabbed the SSH key that it was throwing an error on, and we tried to test it ourselves, and it was not erroring out at all. So it didn't really make any sense. And there's some ideas thrown around that maybe there's some memory corruption, cosmic rays, bit flipping, who knows. So we had no idea what was going on, so we decided to just restart the app server and thought this would never happen again. 6 days later, it happened again. It didn't make much sense. And due to that generic exception handler that I showed you over there, the real exception was actually getting swallowed. So we didn't know what the real error was. So the very first thing we do is decided to add some logging and see what happens. So really simply, import logging, and at the bottom over there, wrap the error message in logger.exception to capture the full stack trace to see what was going on. And we restarted and waited, and 6 days later, it came back again. But now, we actually know what the real error is. It's a type error. It says, struct argument 1 must be a string and not Unicode. And it was complaining about this line number 7 over here, the struct unpack, which is some interesting piece of information it was complaining about. So just so you know, struct unpack, the struct module, it's a module that converts Python values between Python and C structures. It's usually used to manipulate binary data. So if you're reading off a network or a hard drive, you would use this function. It's a very low layer, very basic function in there. And the very first argument, that greater than I, that represents endianness, and that basically tells you what type of data it is. So that's a format string that you're passing to struct to say this is the type of data that you are to expect. And greater than I represents big endian. So it's a very common type of binary data. The really interesting thing is when it's saying argument 1, it's not talking about the base 64 encoded string. That would make a little bit more sense because that's the actual user data. That's the part that changes. It was actually complaining about the greater than I, that big endian number, the static variable there, the static string it was complaining about. It didn't make any sense. So The other part about this is that it should never error at this stage. And what I mean by that is, I mentioned before that this function is used for validation. It's also used for parsing. So a user enters their key, they click OK, everything worked. Later on, when the key gets distributed amongst the systems, it calls this very same function to break the key into its component parts. It was breaking at that stage, which means that it passed validation, and then later on, the exact same key was then throwing an error. Didn't make any sense. It was after validation, and again, could not replicate it. Every time this happened, we sit there like, we have the data, let's see if we can replicate it. No, nothing. It could not replicate that. We did it through a loop. We said, let's do a for loop for 1,000,000 times and just let it go. It's got to break one of those times, and it didn't. Didn't make any sense. So we wanted to take a deeper dive at this point. It's kind of driving us nuts. So we started looking at the error logs to see if anything was revealed there. And what we noticed is when it broke, it really broke. It broke a lot. Looking through the error logs, you see a stream of 200s being produced, and then all of a sudden, you start seeing these 500 errors intermixed between the 200s, which also didn't make much sense. And even from the same stream, you see the same URLs being hit that would call this function. Some of them would return 200, some of them 500. Didn't make much sense. We noticed a strange pattern, though. Approximately 1 in 8 of those calls would fail, and that's when it clicked. You know, we have 8 Gunicorn workers that are running for this particular app. Is it possible that one of these workers were corrupting somehow? Didn't make much sense. During this incident, I'll mention, the reason it was throwing hundreds of errors is because this was being distributed for a large customer. So a customer was pushing out an SSH key amongst hundreds of systems. So this function was getting hit a lot, which is why it produced so many errors in a short period of time. So here's a very crude diagram of what it looks like. You have the master worker process. It forks off 4 workers underneath. Each worker in this particular model has its own Python, has its own process, and it has its own Python context as well. So how do we figure out if, to validate if our theory is true? Moar logging is the answer. Import from OS, and in this case is really simple. We just log the PID. Into the logger.exception, you can pass it an extra parameter to give it extra data. And in this case, we just passed in the PID value itself, just to see if this was the case. And we did the waiting game once again. And again, it happened 7 days later. And it was true. It actually was the same worker. All the errors that were produced, the hundreds of errors that were coming out, they all had the exact same PID. So at least we got something going there. We're finally starting to narrow down. Our theories seem to make much sense. I'd like to remind everyone over here that this piece of code is 2 years old. And in the span of 3 weeks over here, it produced thousands of errors. It had nothing for 2 years. In 3 weeks, it throws thousands of errors. This drives you insane. At least our assumption was confirmed, some little bit of progress. There was a worker, and it was getting some corruption. And it was still ongoing. And what do you do? What do you do with this data? Now that you found something, what next step do you take? So our team was kind of scratching their heads and just trying to figure out how do we approach this next? What kind of analysis can we do? What kind of Moar logging, new strategies, something? And then the problem just stopped on its own. It stopped. During this whole time, our app seemed to have self-healing powers on its own. It resolved itself, and it's something that we actually never noticed previously. In all the previous times that it occurred, we would add some logging, and we'd restart the system, and it would be pretty quick to respond. But in this case over here, we actually left it for an extended period of time as we're trying to figure out what our next move was, and it fixed itself on its own, and perhaps would have fixed every other time itself. And so the next thought is, okay, maybe there's some previous request that this worker handles that triggers this incident somehow, and maybe another sequence of events would untrigger it somehow. Moar logging. That's the answer. This time we did not use, we didn't even touch our function. We plugged into Gunicorn. So Gunicorn has this really nice hook system that allows you to hook into the various points of the request response cycle. In this case over here, we plugged it into the post request, so this is after the request was handled, and we logged a whole bunch of information. We logged things like the method that it was used, like a get or post, the URI, and the status code, and we also threw in the number of requests that particular worker handled, because who knows what it could be, right? Maybe there's some critical number that this Gunicorn hits of requests, and it just blows up. I don't know. We don't know. Did the waiting game, and it came back. At this point, you may be asking, why is it always about a week in between? You know, it's every single time we take an action, nothing happens for about a week, between 5 and 7 days. Maybe at this point, we're like, all right, maybe it is the number of requests, right? Maybe it takes that amount of time for it to accumulate and then trigger that error. Maybe. Everything's a maybe. It was the same story. It was the same PID, same slew of errors, you know, running at this impossible stage. It stops on its own. This time we didn't do anything. We just left it alone, see if it will self-heal again, and it did on its own. So we decided to look at our new logging and see what we got. Nothing. Nothing came out. It appeared that there wasn't any particular sequence of events that caused this. So we looked at all the data. We looked at the past 50 requests, trying to see if we can find some pattern of requests that would hit it. And then we looked back at the previous week of history that would hit, that this worker processed, and you can see the same patterns being hit. It was actually the same pattern everywhere. And it didn't seem to be any particular sequence that caused this. And what's interesting as well through this analysis, what did reveal, I mentioned that all the previous cases, it would break after validation. So it validates and then later it breaks during the parsing. But we noticed this time when it did break, even validation would break. So even users, as the issue was ongoing and they enter new keys, it would break right then and there for absolutely no reason. So it seems that Python at one point says this function is no longer working on this particular worker. Doesn't make any sense. And then it fixed itself without a restart, so you don't have to do anything. And it also did not appear to be related to the number of requests. So there goes that theory. There were some workers that processed 15,000 requests that were broken, and some had 25,000. So it didn't seem, there was no correlation that we can figure out. What do you do? What do you do at this stage? We were pretty much out of ideas of what to do next. We reached the end of our debugging master skills, and we could never replicate this issue. This is the part that drove us nuts. No matter what we did, every time Sentry would give us the nice error, and you get the entire context, you try to replicate it in every single way, because you have to be able to isolate the issue to narrow it down. But we can never replicate this issue. So there was a thought, maybe we should just strip out struct. Let's just get rid of that entirely. Let's go a different route and try to move on with our lives. So a new PR was submitted, which was dramatically simplified, actually. So I mentioned before what this function does is it grabs the first 4 bytes and it tries to see if it equals the integer 7. Well, somebody said, well, it's always the same 4 bytes. Why don't you just hard code it? You know, SSH key prefix there. You have the first 4 bytes, and you ask the question, does the first 4 bytes equal this sequence? Yes or no? A very simple question there. And it worked. However, we did not merge this PR because there's this nagging voice in the back of your head that says you really need to solve this problem. Don't merge it. So it kind of sat in our queue for a long time collecting dust as we just waited, trying to see if this would happen again. We really wanted to solve this problem. And it gave us another opportunity. 5 days later, came back. Okay, at this point, we're like, this is it. this has got to be the last straw. We pulled in every single resource on it, myself, our CTO, anyone that can type into a keyboard or like get on this problem. We need to figure out what is going on over here. And there are a fresh set of eyes on this problem for the first time. And there's a lot of important questions being asked, like, how did this ever work? And you're like, yeah, I know. How did this ever work? Our CTO in particular, he was asking this question. He's like, Chris was saying, like, guys, how did this ever work? And you're like, I know, Chris. How did this ever work? Doesn't make sense. He's like, no, guys, listen. How did it ever work? This first line over here, from future, import Unicode literals. This means that every single string in this file is actually a Unicode string. Even though you put it as a regular string, this is Python 2, it actually converts it into Unicode. So this means that this error over here, this line with greater than I, that's a string, is actually a Unicode string this entire time. Everything is Unicode. And this particular import was added a few months ago, before all this error happened. And it was part of a Django upgrade we were doing at the time and trying to be more Python 3 compatible. So this error now makes more sense. It's like, guys, you're passing in Unicode, I need a string. And obviously that makes sense because everything is Unicode. And for the first time, we were able to replicate our beautiful error. You have from future import Unicode literals, and you run this, and there you go. You get that beautiful struct argument 1 must be a string, not Unicode. And if you take that out, it works. So how does this ever work? Again, we just showed that this should always fail. You put that line in, it should always fail. Months ago, when you added that line, it should have failed immediately. In fact, it should have failed the tests. How did it ever get passed? It doesn't make any sense. Nothing makes sense. So we try to run it. We thought, all right, maybe there's something in Django. So we launched a Django shell, and we try to run it through here, and did the same thing, import Unicode literals, and it works. This doesn't make any sense. So maybe we thought it's IPython. So strip out IPython. Does it work here? Yeah, it still works. What is going on over here? Is Django monkey patching struct for some reason? It wasn't. But at this point, let's just take a step back here. Let's state what we know. This should always break, and it should break every single time, right? We were able to prove that. It should break consistently outside of a Django environment, right? We were able to isolate that. It works consistently within a Django environment, right? We were able to see that. So something is not making sense over here because some intermix is not working. There's something buried in between these statements. So we asked everyone, all right, take each one of these statements, split into teams, let's figure out if we can truly prove these individual statements. And very quickly, someone was able to disprove the second statement, that it breaks consistently outside of a Django env. In fact, it has nothing to do with Django. In a regular Python shell, you launch this, you go struct unpack with a string I, and then you pass in Unicode, and it works. What is going on here? It only works, it only fails if the first call to this function is Unicode. Yes, what? I know, exactly. It only fails, and here you go. It's actually very easy to test. You pass in Unicode first, and you get the error. You pass in a string, it works. You pass in Unicode again, it works. So our thought is, okay, maybe there's some sort of caching going on over here, right? It seems like that. How does it know from call to call what it's doing? There's got to be some sort of cache. So we got to dig into CPython over here to figure this out. And really, this involved just looking up the C code for struct and searching for the word cache. And we were so damn lucky because there it is. Define max cache 100. It's right there, and there's this function called cache struct, and it says if the size of the cache is greater than the cache, then you clear the cache. So there is some caching going on, and of course there's a bug report for it. Struct constructor only accepts string and not Unicode, but because the struct pack uses caching, and it found the string B in there in the cache, and because string B and Unicode B are equal, they have the same hash, so therefore they equal the same thing. So what this is implying is something else somewhere is calling struct with greater than I, and it's getting cached that way. So we're like, how many times is our code base in our virtual env, how many times is this being used? And it was 77 times. So amongst the entire virtual env, 77 times is this particular string being used with struct. All right, now we're getting somewhere. We're trying to figure this out. Maybe it's time to put all the pieces of the puzzle together to make sense. So you have Gunicorn. When it boots up, struct greater than I is called somewhere, right? In there, and it's cached. And each one of the workers, because it's its own process and its own Python context, it stores, it has its own cache. So everyone has its own independent cache that way. And at this point, our beautiful app works. You throw in SSH keys, you can distribute it, everyone is happy. Requests start flowing in through the master and distributed amongst the workers, and any code that has struct greater than I, it decrements the cache counter. So each one starts decrementing at its own pace. At some point, the cache runs out on one of the particular workers, and it hits 0. And this is important. Under the right circumstances, our code gets called. And this is when the error gets thrown. It gets called and it gets passed to this particular worker that has a cache of 0. And this is where you get the flurry of errors. And it actually stays broken. It stays throwing that error until some other request with greater than I as a string comes through, hits that, refreshes the cache, and the app works again. That's the self-healing powers. This kind of also explains why it breaks every week or so, because it takes approximately that much time for 100 requests of struct cache to hit 0. And remember, it has to be the right circumstances. So it has to hit 0, and ours has to be next before another one refreshes the cache. And why did it start breaking all of a sudden after a few months after we added that one import line, the future import? Our thought is, remember I said this is November. Usually at the end of the year, you got some security audits that come around where you need to clean up a bunch of users. So towards the end of the year over here, there's a lot of activity where people are removing and adding users, trying to clean up to look good for the security audit. You should be doing that all the time, but they do it at the end of the year. So this is kind of our theory behind that. The solution was ridiculously simple. Just make it a string and just get on, get on with your life. Really, really simple. And actually, the bug fix was fixed in the very next version, the very next minor version over there. Struct now supports Unicode format strings. Yes. So what are some of the lessons to be learned from here? When things don't make sense, add more logging. No matter what, just keep digging and add more logging wherever you can. At some point, the truth will come will be set free, right? Keep questioning your assumptions. So this entire time, we were trying to replicate the issue over and over, and we kept grabbing the same context and putting it in over and over, but we were not duplicating the exact environment. And it was until new people were on the issue and asking some very important questions to really rock your assumptions there. So you got to keep questioning your assumptions and keep trying to replicate no matter what. It sounded very tiring. Trust me, after 6 weeks, you're like, I've seen this error, I've seen this error, I've seen the same struct unpack line too many times, I'm done with struct. Don't use generic exception handlers. We thought it was a good idea to add it because, like, why would it break? Well, if it's going to break, let it break. Let it break, find out what the true error is, and then maybe add a very specific type of exception handler. Don't use generic exception handlers. Doesn't make sense. Be very wary of this future import line. I mean, it makes sense to do that, but don't just go and put it in every single file like we did, because this has some strange ways of rearing its ugly head. I mean, it kind of goes to show that, you know, complex code creates very complex problems. That's everything. Thanks for listening.
So thank you so much, Hany. We have time for questions, if there are any, but I've been told not to move the microphone around. So if you have questions, I will either repeat the questions or you come in front and state your question. Yes.
Oh.
Did you ever figure out why it was always the same pit that was causing the problem?
The question was, did you ever figure out why it was the same PID?
Why was the same? So it was the same PID in that family of unicorn workers, and it was the same PID during the error. Not every single time the error would occur, it was a different PID, but it was the same one during that sequence until it self-healed itself. So it wasn't the same one every single time, like the same PID ID. It was during that session. Yeah, that lovely session. I'll let you.
How many eyes did you have to have on that problem, and how much it cost the company if it's not too much info?
So,
I'm curious to see how many manpower you put on that problem.
so the question was, how many eyes and how long?
And how much money did we spend?
And how much money did you spend on this?
Way too much money. Every time the incident happened, it was mostly our engineering team, and there was particularly two or three guys on it at any particular time. That last stint, it was everyone. Like I said, anyone that can type into a keyboard, you're on this problem over here. Just look at it. You don't understand code, doesn't matter. Just go read it. You gotta give us your opinion. So we probably spent too much money in that last session, but this is 6 weeks in. We have to figure it out.
Okay. Someone from the back over there? Yep. How do you parse your logs?
How do we parse our logs? Good question. At this time, it was actually just raw logging. Now we use centralized logging for that, and we have a tool. We use a partner called LogDNA, which is actually a pretty slick logging company, and so it allows you to aggregate and allows you to dig in and filter through it. So if we had that a year ago, probably would have been a little bit better, although it wouldn't have revealed this true error towards the end. You really had to dig. But back then it was just raw logs, just raw Apache logs. And then we did our own logging, right? When regular logs don't work, you got to go commando on your own.
So once you were logging all the requests, did you try replaying all of them to see if the problem duplicates?
Oh, yes. Yes.
Okay, so once you had all your loggings, did you try replaying them?
Yeah, when I say we tried to replicate it, that's all we did.
Figure out why replaying the request didn't replay?
So it was... We didn't replay enough of them because basically we had to replay an entire week, right? So yeah, we didn't go back 6 days. We went back, 200 requests, 300 requests. I thought that would have been enough time to really find some sequence, but you really would have to go for the entire week to get it down to 0, and then that particular. So even if you're to do that, you're still not guaranteed that the order, because there's a slight randomization to which worker it would hit. So it had to be the exact same circumstance. So even if you did the same sequence, there's no guarantee that that the next request that would break it would hit that right worker.
And you couldn't produce it at the worker level.
Yes, we could not. Yeah, exactly.
Yep.
You mentioned that you were using, I think you said Sentry, and you had access to the full context of the function call.
Yes.
And then I'm assuming that would have included the telltale sign of the Unicode structured template. I was wondering, were you guys just testing in the Django shell using those arguments, or why didn't the fact that one of those parameters was Unicode cause that issue to be replicatable earlier?
Do you want to repeat that? So
Repeat it.
I'll do it. So I think the
I'm
question
not into
is.
Django, sorry.
Yeah, I think your question is, in Sentry you have the full context. It should have had Unicode in there, and we should have been able to see that. So I guess because of the way that future import works, and this being Python 2, it didn't necessarily translate that and print out that it was Unicode. It printed out that it was a string. I guess there's some magic or something that goes behind it. So Sentry didn't translate that into it. So when we're looking at it, it looks like a string. And again, you drove us nuts, right? You're doing a string. Why are you telling me it's Unicode? This code's crazy.
How did you reason about not deploying the fix you had? So when I'm responding to mission, the first thing I do is like stop the bleeding. We can figure out a root cause later. But how did you come to that?
Okay,
It's
so the
very-
question is,
yeah.
why did you not deploy the fix that you had?
Yeah, so being a business guy, I probably should have made that call, but I also have a tech background, and like I said, there's that nagging voice in the back of your head saying, don't back down from this. This is seems like an interesting problem, and the fact that it's self-healed, I think, is what really drove us to try to dig it in. I mean, if it just kept airing out, maybe that wouldn't have given us the impetus, but why does it self-heal? Right? Why does it all of a sudden fix itself? That sounds like a very interesting problem. Made for a good talk. So it was a very interesting problem to solve it. You know what? If we had no more ideas at that point, and there were a few points where we thought we had no ideas, but there was still some more. If we really truly had none, we probably would have merged it. But as soon as we started getting on the tail, and as soon as we started unveiling that, depends on the order, then we were hot on its tail. You can't let it go. It's a good problem.
Okay, so thank you very much, Hany.
Thank
I
you.
really appreciate your talk. I'm much into debugging.